So before we start, let me tell you a little bit about what we're going to do today. But there's an absolute beginner session, as I just said, and you don't. I don't expect you to know anything about Hadoop or big data, and we'll start right from the scratch. We'll look at. So these are the topics for today. We'll understand what is big data. We'll look at a case study where we'll show you how does a traditional warehouse look versus Hadoop and what are the advantages of doing that. Then I'll also touch upon why should someone learn Hadoop depending upon your background and the related technologies. We'll also look at the jobs and trends in big data, the kind of career, if you're looking for a career change, or if you're looking to move into a Hadoop project in your organization itself, how will that benefit you and what are the upcoming trends about on that? Okay. Then we'll go into a little bit of detail on the Hadoop architecture and the ecosystem. I'll tell you the various tools and technologies which are available there, how do they work in tandem, and finally we'll take questions. So now the best time to ask a question is when you have one, right? So don't wait for me. At times I may not be able to take questions because there's a free class, so there are a lot of people in the class, but still I'll try to answer as many questions as possible within the time, and I'll take logical breaks. So in the next 1.5 hours, I'll try to take you through all these things and take questions. So you can ask questions, any questions related to the topic. You can ask questions about your background and whether you are the right candidate to get into Hadoop. Okay, and what are the uh, what are the advantages or whether it will be good for you or not. So let's get started then. I have a lot of people in the class and from various places we have. Can I quickly get a poll on your location as well? How many people are from US here? If you can just give me a yes, I'll be able to see that. And then, because just want to make sure that we are good on time and it's not too late for the people. Okay, so great. So we have Eric, Ravi, Ramya, Srikant, Jeff, Satya, Ranjit. Okay, so we have almost like 25 people. That's what the poll shows me from US. Okay, and more people are joining in. How many people are from India here? Okay, okay, great. So a lot of participants from India as well. Okay, great. So without further delay, let's get started with today's topic. As I said, the objective of this session is to understand what is big data and to understand what are the opportunities for you in big data, and we'll also talk about the Hadoop architecture and the ecosystem and related technologies. Okay. So what is big data? Now, a lot of people think that big data is only about lots of data, which is true, but not entirely true. That doesn't give you the exact picture. So it's surely about lots of data, terabytes or petabytes of data. Now, if you look at the definition of Hadoop or big data is the term for collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. Now, this is not only because of the size of the data, but also because of uh, the variety of the data which you get. Okay, the kind of data which you're getting, it's not just purely structured data which we get these days. I'll talk more about what is structured versus unstructured data, but it's not just the size of the data, it is the variety of the data, it's also the speed at which the data is moving into your system. Okay, and then the challenges which add because which come in because of this data are how to capture this data, how to remove anomalies from this data, how to store this data in a most optimized way, searching, sharing, transfer, more importantly, the analysis of this data, and finally visualizing this data to get some meaningful insights into your business. So these are the challenges associated with big data, and big data is not just about the size of the data. It surely is about the size of the data, but not only about the size of the data. Okay, so now, what is this? What is this unstructured data, and why has it become so popular now? So, if you look at this plot, it shows that during the 90s, you mostly had relational data. Relational data refers to the data which can be which is structured and can be stored in a table structure. Whether in an Excel, we are all used to looking at that data where you have, say, employee information, a salary information, or you have various uh, databases where you can store structured data in terms of multiple rows and columns, right? Now, what has happened is that in the past decade or so, we've seen a lot of unstructured data and complex data coming into play, and and all businesses, all architects, all data analysts want to analyze that data and gain insights into what are we into your business. You want to understand how your customers are behaving. You want to understand who are the potential customers for your product, who are the customers who are happy with your service, who are the customers who are not happy with your service. So these are the various insights I want to gain to grow my business. And that's where all this complex and unstructured data has come into play. Now, what does this complex and unstructured data comprise of? Okay, so obviously the data volumes are increasing. The complex data or the unstructured data comprise of all the data which you get from social media, Twitter, Facebook, weblogs, LinkedIn, right? The comments you put in a Facebook post, or the videos which you share, or the kind of pictures you like, right? The emails which you send, that's also complex unstructured data, right? And then a lot of data which you collect from various sensors. I mean, they can be various sensors. Say, for example, you want to collect the traffic data, right? What is the traffic movement at a particular point right now? Okay, that's collected through a sensor, or the weather data which you may want to collect, right? So these are all forms of data which were unknown a decade back. No one was analyzing them. A lot of people were collecting them, but the challenge was how to analyze that. Now, today, the challenges which come along with this data is that how do you everyone knows we want to analyze this data, right? How many people have actually handled such data in this class? Can I get a yes or a no from the folks in the class, please? How many people have actually tried to, or if not analyzed, have been asked to analyze, or have this challenge of analyzing such data? You can just, okay, you can just give a yes. Okay, so we have Rajesh which says yes. Okay, we have Jeff who says yes. Okay, uh, Eric says I have not analyzed. Right, I understand a lot of you may not have analyzed, but I'm sure a lot of you may have seen the need of analyzing this data, right? So that everyone agrees with that, right? Okay, so a lot of people have actually tried that. Great. So, so these are the new. This is the new type of data which you get, whether it is from, say, an airline sensor, or you get it from the stock exchange. What do you want to do? I mean, how many people here understand the difference between OLTP and OLAP? I would just like to tell you a little bit there. So, okay. So, well, a OLTP system or a OLTP store will store all your transactions. It refers to the online transaction processing. So, whatever transactions you're doing, say, for example, all your credit card transactions or your banking transactions, on a particular, each transaction will be stored in a OLTP data base. Okay, so what you will be doing there is that you will be looking at the current situation of your system. Okay, you're not worried about the history of your system. Whereas OLAP, which is the online analytics processor, will be processing system will be storing all your historical data. It may not have the transactional level granularity, but you'll be storing the summary of all that data. So what do we do with that? We want to do a historical trend analysis, right? Say, for example, if you have a if you want to analyze how many people use an ATM on a particular at a particular location, a bank would like to know that, oh, okay, if there are a lot of transactions happening from that ATM over a period of time, then and if you're overloaded, then maybe it's a good time to install another ATM nearby. And if there are not, so this could be one example of what we would like to do. Then you may want to analyze what are the kind of uh, who are the type of customers who are actually getting interested in your product, right? Over a period of say last 6 months, who are the customers who bought your product? What were their activities behind that? So that's another example of the historical data which you would like to look at. Another example will be, say, in a stock exchange, you want to look at what type of stocks are gaining popularity now, right? And how are they affected by the other factors? Maybe the change in government, change in the policies, or maybe the FDI is open in a particular country for, uh, uh, and how many. So, what are the various stocks doing over a period of time? So, all this is done through online analytic processing. Now, so this was all done, right? This is not something new. We've been doing this for a long time now. Okay, what do we want to do now with a system like Hadoop or the related technologies is we would like to predict that, okay, if this is the behavior a customer shows, whether he is a potential customer who's going to buy my product, right? Say for example, all the e-commerce sites would like to know that, okay, which customers to target for a particular campaign, right? Which are the customers which may end their subscription? Say for example, I want to do, there are two categories: new customer acquisition and retaining old customers, right? So retaining old customers, or the customers who leave you, is called the churn analysis, right? That how many customers do you think you will be able to retain and how many customers are going to leave. So this is another analysis which we do, and for that our traditional systems are not built to do that, right? So we do a lot of predictive analysis, which is a very hot thing these days, where we want to analyze from predictive analysis that if a new customer or if a new potential is doing some activity, based on his activity or his behavior, I would like to predict which product is he likely to buy and when, so that I can target him at that time, right? And not disturb a lot of people. Then the second analysis, so this is about acquiring new customers, use of predictive analysis there. Then the second kind of analysis I want to do is that the churn analysis, which where I want to know that, okay, who are the customers who are likely to drop their subscription. A lot of telecom companies want to do that, right? So to offer them new schemes, new discounts. So these are all the applications which are new age applications where your traditional systems don't really work, right? So looking at, so and these are done through analyzing the new type of data sources, maybe what they share, what they're saying about your product on social media, the emails which they send to you, the kind of data which you have about them in your databases, and sometimes you may want to look at the sensor data as well. A lot of the sensor data is analyzed in medical applications as well, right? So let's look at what are the challenges. And so the good news here is that big data is here. We know that there's a lot of data which we can collect and do a lot of analysis. Now the bad news or not so good news is that everyone is struggling to store, process, and analyze it using the traditional methods. Okay, so okay, so this is what we do. This is the bad news here. Now let's take an example of who could be the customers who would be doing this. Now I've not taken a lot of examples, but let's take a couple of examples. Now banks and financial services, right? You want to model your risk. You want to do fraud detection. Say for example, you want to look at some credit card transactions and you want to do some fraud analytics over it. That's where you would like to analyze, okay, this particular say transaction is happening from a particular IP, and the size of the transaction is above a threshold. So you may want to alert your customer that, okay, this could be a fraudulent transaction, and you may want to check with the customer so that on real time you may get prevent a fraud from happening, right? You may want to also look at the credit scoring and analysis of your customers. Based on that, which you can give them a loan at a particular interest rate. So these are the various applications in the financial services. Now in retail, a lot of people have started analyzing their data in retail. And say for example, point of sales transaction analysis, as I was talking about, customer churn analysis, which means the kind of the type of customers who you may want to retain, or drop which you're seeing in your existing customers. They've opted for a different store, or they've started going to a different website to do do their transactions. And also sentiment analysis, where you launch a new product and you want to see what are people talking about your product, whether they're talking positive about your product, or people are talking negative about your product. What is the response to your product? And all this analysis you want to do in the fastest possible time. You don't want to wait for weeks and months for you to know that, okay, what was the effect or what was the impact of the new product which you launched, right? So let's take a case study of Sears itself and understand what was Sears doing earlier and what are they doing now, and how are they taking advantage of the big data and Hadoop ecosystem. Okay, so Sears, as everyone knows, if you don't know, Sears is a big retail chain where they have a lot of customers coming in, and they want to analyze their behavior, and they want to look at some key metrics or early indicators which can lead to increase in business. Obviously, everyone wants to do that. Now, earlier Sears was using a traditional system, using Oracle Exadata, Teradata, and SAS to store and analyze their data. Okay. Now, uh, the next this is how it looked like. So this is how your traditional data warehousing application or a ecosystem or a architecture looks like, where you have a lot of data which you collect from various sources. Okay, and mostly it will be stored in your storage only grid. Now all this data, when it reaches above say a 10 terabyte of scale, then it's very difficult to move into a compute grid. So what you have here is your storage grid, which is getting this data from various sources. There's your storage grid here. Okay, and then you extract the data and you move it to your ETL compute grid here. Okay, now the challenge here is that 90% of this data gets a premature death. You cannot move beyond a certain size of the data into your compute grid, because it doesn't scale beyond that, right? So what you do is that you look at only the important data which you believe is important, okay, and you move it to your compute grid where all your processing happens. So, and then you do a lot of BI reports. You can have interactive reports there and apps where you can do analysis on your historical data. Now, the challenge in this case is the fact that you are not able to analyze all your data, which you would love to, right? I mean, you don't want to leave 90% of your data archived and not use that data in your analysis on how are people behaving with your product, right? So what did Sears do? So this was the challenge which they were facing earlier. What they did was that, moving from this storage only grid, they moved to Hadoop. Okay, now they right now they have a 300 node Hadoop cluster where they keep all their data. All their 100% of data is available for storage and compute, right? So there's no data archiving, as you can see here. Now the advantage which you get is that their entire 2 petabytes of data is available for compute as well. How is this made possible is something which we'll explore going forward, that how does Hadoop is able to achieve that. That's something I'll tell you as we move ahead. But just to give you a view of now what you can do with this. Now earlier you were losing 90% of your data as archive. Now with Hadoop coming into play, you can actually keep all your data in, and you don't have to worry about archiving the data and getting the data back from your archive. You can analyze the complete data, right? So that's the change. And it may not look so apparent on the a slide or a foil, but imagine if you could analyze all your data and do analysis based on that, rather than doing the analysis of a sample of your actual data, right? So everyone wants to do that. That's why Hadoop is gaining popularity, and that's why it's fast replacing your traditional data warehousing systems. Now, at this point of time, I would like to take questions. So, if you have any questions here, I'll be more than happy to answer them. Okay, so I have a few questions coming in here. Can you give example of some sensor data? Yeah, so The examples of sensor data are, say, the data which you're taking from a weather sensor, right? You want to analyze what are the temperatures, humidity at a particular place, or you're trying to get data from an airline sensors. So these are, or medical sensors. All this data is an example of transactions, right? Now, okay. So there's a question: daily, day-to-day transactions are stored in a relational DB, right? Okay. So your daily transactions, day-to-day transactions will be still be stored in a OLTP system where you will be putting them. Now, a OLAP system will be storing your summary of those transactions on a daily basis. In Hadoop, you can store all type of transactions. So we can move unstructured data as well, right? So all the unstructured data can be moved into this. Well, after you still need to archive after some point of time. Yes, you may have to, but then in Hadoop, the limit of the storage is unlimited, right? And with Hadoop 2.0 coming in, you don't have to really worry about archiving of your data. You may still want to replicate this data, duplicate this data, and store it there. But when you analyze your data, you have the advantage of analyzing all your data. Okay. So, any more questions, guys, on this particular thing? Okay. Okay. Can you please explain about nodes? Sure, Ramanathan, I'll just take it in a while. What is a cluster? Will it be binary? Yes, the data will be stored in, well, the data can be stored in whatever format it is. Okay, so you don't have to really worry about what format of the data. You can store videos, you can store audio, you can store your text files, you can store your emails. Whatever you want to store, you can surely store that data in Hadoop. Okay. Okay. What is the upper limit of data in Hadoop? As I said, right? I mean, there's no upper limit as such in Hadoop. You can store tens of petabytes of data in Hadoop, and I'll explain you how is that possible in a while. Okay. Okay. Even with Hadoop, data has to be stored in RDBMS for analysis. No, you need not store your data in RDBMS for analysis. You can directly do analysis from Hadoop. There are various tools and in the Hadoop ecosystem. I'll talk about that when we get to the Hadoop ecosystem. Okay. What is the key difference between RDBMS and Hadoop? Okay, so the key difference between RDBMS and Hadoop is that in RDBMS you can only store structured data, and there is an upper limit to the scale of the data which you can store. In Hadoop, you can store any amount of any type of data, any variety of data, and if you can store, you don't have to worry about the scale of the data. Okay. Is ETL obsolete with Hadoop? No, that's a very good question. It's not obsolete, but Hadoop gives you a bigger view of ETL. You can. I mean, Hadoop also has a ETL tool which is called Pig, so you can do your ETL on a much larger size of the data. Okay. Well, is the only difference between traditional systems and Hadoop is the volume of data you can store in Hadoop. Not really only the volume, the variety of the data, the kind of analysis you can do using the Hadoop ecosystem. A lot of things come in become possible with Hadoop. We'll be talking about the what is the size of data Sears is having. So at the time when this analysis was done, the Sears was having uh, around 2 petabytes of data. Has the organization tried for compression techniques? Well, not the whole data is structured, Nitin. We have a lot of data which is not structured as well. The 2 petabytes of data when we were using in our traditional data warehouse, we could not move this whole data to compute grid. Now, the thing which changes with Hadoop is that you don't have to move your data around to the compute grid. The computation happens where the data resides. I'll talk more about it. So as we move ahead, but that's a very key difference. So there's no limit on the size of the data. Okay. Okay. You're able to hear me, right? I mean, someone said they lost the voice. You're able to hear me? Okay, great. Sure. So, okay. I'll take a few more questions before I move on. So Eric is saying, so the data from the point of sale is available for analysis right away in Hadoop. Well, not right away, Eric, but you can move your data into Hadoop. There are related tools and technologies where you can do real-time analytics as well. Storm, Spark is one. I'll talk about that when we get to the Hadoop ecosystem. That how can you do real-time analytics? But yes, you can move all your point of sales data into Hadoop. But you can, and Hadoop is mostly for batch processing, but there are tools available on top of Hadoop where you can use, where you can do real-time analytics as well. Okay. Yeah, Sai, if you have more questions to ask, we'll take questions after the class as well. So in case, is it possible to use ETL tools like SSIS or Informatica with Hadoop? Yes, it is possible. Now there are connectors using which you can connect your Informatica to Hadoop as well. Okay. Okay. So I'll talk about that as well, Nitin, whether it is necessary to have a data background to learn this. Srinivas is asking me what is the difference between Hadoop and cloud computing. Well, Hadoop is a framework of tools which you can use to store and process your data. Cloud computing will be the infrastructure which you can use on Hadoop. So most of the Hadoop systems are built on cloud. Okay, so you can say, for example, you can take your all your machines where you want to store your data on cloud, on AWS or on Azure as per your needs. Okay. Satyajit, I'll take up your question. Okay, I'll take up your question in a while. Okay. Okay, since Hadoop stores 100% of data available, will there be impact on latency of analysis? Well, yes. So, as I just said, in Hadoop, Hadoop, in pure Hadoop, only using Hadoop, you cannot do a real-time analytics. Okay, for that, you need to use another tool which we'll talk about in a while. Okay. Can you explain value veracity? Well, veracity refers to the the truthfulness of the data. Now, what that means is that say let me explain this with an example. Now you wanted to analyze your data. Okay, you wanted to analyze the behavior of your product on social media. Okay, there's a question I'm answering which is, what does veracity mean in terms of, so there are three V's using which uh, we define big data, which is volume, velocity, and variety. There's another term called veracity, which means the truthfulness of your data. Which let me explain that with an example. Now you launched a new product on a weekend, okay, and you saw and you wanted to look at the response of people on Twitter for that product. Now that was a long weekend, for example, right? And the only people who actually gave a positive comment for that were people who were staying back on that long weekend. And you thought that this is the only day, and you thought that, okay, this is the source through which I can get the responses to my data. Now it is very much possible that the type of people who responded owing to the long weekend or any other factors was not the right size of the people, or not the right people whom you wanted to get that analysis from, and you took a wrong assumption on that and you started building that product. So this is where veracity of your data comes into play. Suresh, I hope that explains. Okay, so another example could be that you wanted to launch a new HR scheme, and you sent a communication to all your employees on a weekend, and what you got was not the right response, because the people who were really getting benefited or getting affected were not available at that time, right? So you need to also look at the source from where you're looking at your data, from where you are looking the from where you're getting your data for analysis, right? You wanted to launch a product in US and you got the feedback from Africa. That's something which will lead to a wrong analysis, right? Okay, so can Hadoop be OLTP and OLAP? Yes, it can be. Okay, so Can you explain single node and three node in Hadoop? I'll take care of that. I'll explain you that. How to send requests from external system and how to pass back results to the external system. Suresh, just hold on for some time. I'll be talking about that when we come to the ecosystem. Okay. Is data security a concern in Hadoop for a bank? Uh, well, like any other system, there are security concerns, but there are ways to handle that, Herman. Okay. Now, can we connect Hadoop with statistical tool like SAS or R? Yes, you can. You can definitely connect Hadoop with SAS or R. In fact, a lot of analysis on Hadoop there's a Cloudera, Hadoop and SAS have a connection, and there are connections available for R and Hadoop as well. And that's a very popular open source architecture where you have your Hadoop as your data store and R as your statistical analysis tool. Okay, so okay. Okay, so when should an organization move to Hadoop? Like if my data is above 2 petabytes, etc. Well, if your data is unstructured, if your data is growing very fast, and if your data goes beyond, say, a few terabytes, you will not be able to handle them through your traditional systems, even if you cluster them. So, say for example, you may cluster your data, cluster your complete data, and use a Oracle or a NetEase there, but still you may not be able to get all that data, and these systems start breaking when you scale beyond a few terabytes, maybe above, say, 10-15 terabytes. You will not be able to handle that. Okay, I hope that answers your question. You said Hadoop can also handle OLTP application. No, not really. If I said that, pardon me for that. You store your OLTP transactions not in Hadoop, but your OLAP can move into Hadoop. Your all your data which you were moving into your warehouse can get into Hadoop. Okay, I'll talk about the infrastructure as well. Okay. Okay. How does Hadoop will change an analyst's life? Okay. Well, good question, and that's what we're talking about, right? Analyst, if you're an analyst, Hadoop is very good news for you, because now you can analyze any kind of data. You're not just limited to analyzing data which is available in Excel sheets. You can analyze any kind of data. You can analyze a huge amount of data. You don't have to worry about taking a sample of that data and only analyzing that. You can do, and also you can analyze your data in real time using Storm on Hadoop. Okay, I'll talk about that as well. So let's move on. We'll take more questions on this as well as on the other things as we move ahead. And if one of you wants to speak, just let me know. I can unmute you as well. Okay, so why move to Hadoop is the question, right? I mean, a lot of you had this question. Now, what does Hadoop bring in? It allows distributed processing of large data set across clusters of computers using a simple programming model. Okay, so what does Hadoop do actually? Now, say you have your petabytes of data. Now, you do not store all this data on a single location. In Hadoop, you can store this data across a cluster of computer or cluster of commodity hardware, where where you don't need a very high-end machines for storing this data. Hadoop infrastructure will look like you'll have a name node which is for keeping your metadata, which is the data about your data, and then a large amount of clusters of computers which are called data nodes, where you can store your data. Okay, and all this can be done through a simple programming model. Your data can reside anywhere, and you can store that data, and there's no limit to the amount of data you can store there. Okay, so the Hadoop architecture has two core components. I'll talk about that. And so the basic thing with Hadoop is that instead of storing your data at a single location, you can distribute this data across a clusters of computers. Okay, so that's how Hadoop stores its data. And then you can control all this data, where to store data, where a particular data is stored, through a name node, which is a very high availability machine, which can be used to the which does not store your actual data, but the metadata about that data, which means that where is the data stored, if I have to move a new data, where to move it, which of your clusters are failing, all that, and all that information is available with the name node. Okay, now this is how the data is stored. It has become the de facto standard for storing, processing, analyzing hundreds of terabytes of and petabytes of data. It is cheaper to use. So since Hadoop is open source, it's much cheaper to use. You don't need you can store it on commodity hardware, because the fact that some systems will fail is built into the system. Okay, so it is built into the architecture. So failures can be taken care by the Hadoop ecosystem itself, right? So the Hadoop framework can take care of the fact that, okay, as a particular system is failing, some nodes are not available. So what so you can fetch the data from alternate nodes. So redundancy is built into the system, which means all the data is replicated multiple times in the system. The default replication is 3. We will talk more about that. May not be in this class, but in later sessions which we'll take in this course, we'll go into details of that. But for now, you can understand that the Hadoop framework stores data across a clusters of computers with a name node which handles all the metadata. The Hadoop framework takes care of moving this data into to particular locations, looking at failures, and then how to run your application on that data is all taken care by the Hadoop framework. Okay, and it can store all types of data, as we said. Okay. Now coming to the fact that a lot of people had this question that whether it is good for me from my based on my background. Okay, so that's what Dice says, that we and someone said we've heard it's a fad, heard it's hyped, and heard it's fleeting. Yet it's clear that data professionals are in demand and well paid. Tech professionals who analyze large data streams and strategically impact the overall business goals of a firm have an opportunity to write their own ticket. So that's what the managing director of Dice.com says, Alice Hill. And it also says that, sorry, it also says that the salaries for Hadoop, NoSQL, and MongoDB are all north of $100K. So this is the average salary which you can get. I'll quickly take you through another report which talks about the demand in Hadoop. Gartner says that there will be 4.4 million IT jobs to support big data by 2015. So this is the Gartner report. And then very important thing for all of you here is that only one third of this big data scale requirements are met. Two-thirds of this data requirements are not met. We do not have skilled professionals. So that's where the opportunity lies for all of us to get into this. And then these are some of the type of jobs which you can get into. You can become a data scientist. I'll talk about what is a data scientist. You can get into data visualization, research analyst, big data engineer, where you can be a developer or an administrator or a QA professional, architect who can be a solutions architect for a big data project, and a big data analyst. So these are the various jobs which you have, and this shows, this is all from the Gartner report which I've picked up. 18% of the jobs are filled for a big data scientist. 82% of the jobs remain unfilled, will remain unfilled depending upon the current skill set of the current professionals which you have. So this is where a big opportunity on the orange side lies for all of you and all of us here. Okay, so I'll talk about what can various type of professionals get into when we come to the Hadoop ecosystem. But this is just to give you a view of the demand of Hadoop right now. This is again a comparison from the same report on the kind of salaries which are there for Hadoop versus various other technologies. So you can clearly see that Hadoop is the leader here with salaries up of 1.05 K USD. So all these salaries are in US dollars. Okay. Now, if you have more questions here, otherwise I'll move to understanding the Hadoop ecosystem. Okay, so so there is no scope for Hadoop admin. No, not at all. I mean, there is a big scope for Hadoop administrators as well. There is so all the people who are from the administration background can become Hadoop administrators. When I said big data engineer, that refers to developers, engineers, and to all the people who are from the QA background as well. Okay, so there's a huge demand for Hadoop administrators as well. The people who will set up this cluster, who will analyze the cluster, who will handle the security side of things on the cluster, all these people get into the Hadoop administration side. Okay. Now Raju says that I'm from testing background. What is in Hadoop for me? Okay, so well, if you're from the testing background, well, as we write more and more applications on Hadoop, there's a huge demand for testing professionals as well in Hadoop. So for people from the QA background, there's a huge scope for you as well to get into Hadoop. You need to understand the Hadoop ecosystem. You need to there's a programming model called MapReduce, and there's something called MR unit, which is the unit testing environment for Hadoop. You can get into that. Okay. Uh, then, okay, I am from a non-Java IT domain. Is there anything for me in Hadoop? Well, Anil, you need not be from a Java background to get into Hadoop. In fact, even if you don't have a programming background, there is a lot of scope for you in Hadoop. So, though the MapReduce programming requires Java, but you can do it in Python, you can do it in Perl as well. Python is again one language which is very, very popular in Hadoop. In big data analytics, so you can obviously get into that if you want to get into the developer side of things. But if you're from, say, a data analysis background, or you're from or you want to say you're from the administrator background, you need not know a programming language as well. So you can even become a data scientist, or a Hadoop analyst. Okay. How is the Indian market? Well, the Indian market is growing very, very fast. All these reports, right? A lot of this work gets into the Indian market as well. So there's a big requirement in the Indian market as well, and in fact, in the Indian market, you have even less people who are trained in that. Okay. Will we have access to these slides after the webinar? Yes, you will have that. Reno says, I'm an application support engineer. Which area of Hadoop can I get into? Okay, sure. So you can surely look at the data analysis side of things. Reno, you can also you may also want to also want to look at the Hadoop administration side of things. Okay, so so definitely there's scope for you as well there. Okay, so I'm an ETL ab initio developer. Where do I put myself in Hadoop? Ravi asked that question. Well, Ravi, since you are from the ETL background, Hadoop is very well suited for you, because that's where most of the people get into. So there are tools in Hadoop which are Pig and Hive, which are for ETL and data warehousing. You can move into that. So you can look at that as. I'll talk more about what are these tools all about, and then I'll tell you about that. Nilesh says, I'm a database developer working on Oracle. What will Hadoop be for me? Okay, so if you're working on Oracle as a developer, you can surely move into Hadoop. Your background will definitely help you getting in there. Okay. Okay. Is it true Hadoop is very beneficial only for data warehousing professionals there, because they work on these type of projects? No, no. Though there is a huge requirement for people from data warehousing background, because of the nature of the fact that people are moving their traditional warehouses into Hadoop. There is a huge scope for developers. If you're from Java background, or you're from a Python background, then you can move into Hadoop. If you're from a .NET background, then also you can get into Hadoop. Hadoop, though, is written in Java, but there's something called Hadoop streaming, using which you can develop your Hadoop programs in any language, be it Java, .NET, or Python, Perl. Okay. So it's not just for the data warehousing professionals. The data warehousing professionals will be mostly working on the Hive and Pig tools in Hadoop. Okay. While a developer will be mostly working on the MapReduce programming there. Okay. So I already answered that question, Savantika. What is there in for an analyst in Hadoop? If you're a C++ developer, you can surely get into Hadoop. If you're a developer, you can get into Hadoop as a developer. So there's no problem. Okay. Uh, okay. Is it equivalent to parallel computing? Allow me some more time. I'll come to that question. Okay. I'm from a .NET background. Well, if you're from a .NET, you are from .NET background, you can still get into Hadoop. There's no problem at all, because I mean, if you want to get into as a developer, you don't need to know, say, advanced J2E, advanced Java. You can if you have a good understanding of the object-oriented concepts, you can do programming in Hadoop as well. Okay. Okay. Sai, I can unmute you at the end of this session. Okay. Will that be okay? Okay. I'm a knowledge manager with Accenture. I manage our knowledge websites on SharePoint. We do web and data analytics, but we use very less of programming. Will Hadoop help me? Well, yes. So if your data becomes huge, Gaurav, then in that case you will be, when you do your analytics, you will be it will be good to move your data into Hadoop, and there you will be able to actually look at you'll get a very good picture on the kind of analysis you can do on your data. Okay, so you don't really need a lot of programming there. If you're looking at it from a data analysis point of view, there are tools in Hadoop where you can do a little bit of programming and configuration, and you can get a lot of reports. Okay. Okay, I'm from a Linux admin background. How can I get into this industry? Samim, if you're from a Linux administration background, you can get in as a Hadoop administrator. So for a Hadoop administrator, typically people will ask you for an admin background, and you are very well suited for that. Okay. Okay, what skills are required to become data scientists? Okay, good question. So as a data scientist, your role will be to not only restricted to analyzing the data, but to look at how to acquire the data, how to apply various clustering classification algorithms on that data, and finally do analysis on that data. So you need to learn. You need to understand the Hadoop ecosystem, understand the Hadoop architecture. You need to. It is highly recommended that you understand either R or SAS for that. But typically, R is the more popular language for data scientists. You should also understand the various machine learning algorithms, clustering classification algorithms, and if you have that skill set, then you can get into become a data scientist. Okay, Satya. Okay. Okay, so a data scientist, Herman, basically is a person who will not only analyze the data which is available, but will also be doing some analysis on the future. Okay, so based on your current data, you can actually predict whether a particular customer is going to buy your product or not. So that's called predictive analysis. So a data scientist will be involved in such activities as well. So not only just analyzing what has happened and what is happening, you also should be able to use these machine learning algorithms or data analysis algorithms to predict the future. So that's where the whole new stream of data scientists comes in. Okay. So Gaurav, you can look at depending upon your background, you can look at learning, say, analytics side of things. You may want to master R programming, R language for that. It's not really a programming language as such. It's very simple. You can write small procedures and you can get a huge. So R has built-in tools for built-in packages for doing various type of segmentation, clustering, classification algorithms. You can look at R there. Okay. Uh, uh, Savantika, as I said, right, you can, if you're a data analyst, you may want to become a data scientist. Okay, I have around 14 years of experience as a SQL developer. Which area of Hadoop will I focus on? So if you are a SQL developer, you can look at Hive, where you write actually very similar queries to what you write in SQL. You can so Hive has a query language called HiveQL, which is very similar to, and Hive is used for data warehousing and and for data analysis on top of Hadoop. Okay, I'm a project manager in mainframe and would like to move over Hadoop. Do you think I may have an opening in this space for management position? Well, Pandurang, as there are positions for each profile, there is a requirement for managers to manage these projects. So Obviously there are openings for people from management background, and since this is a very new thing, so you do not have a lot of people who have experience in managing these projects, so you can definitely move into that. But I will strongly recommend that you should understand the Hadoop architecture and how does a Hadoop project look like. So that's highly recommended. Okay, to know before moving into a project management role. Okay. Okay, so I'm a telecom software professional. Well, working on Java, if you're from a Java background, it is a natural progression for you because MapReduce programming is done in Java, mostly done in Java and Python. So you can surely get into that. Okay, you're from banking domain, used using primarily DBMS in the banking industry. A structured data is mandatory as it is transaction oriented. Yes, so your transaction data still goes into your RDBMS, Anand, but if you want to say analyze the credit scoring of your customers, if you want to create new products for your customers based on their behavior or their credit history, then you use Hadoop, and all this analysis is done using Hadoop. So there's a big application for Hadoop in the banking domain. Okay, I am from mechanical background. What is Hadoop for me? So, Rajesh, if you're from a mechanical background, what are you doing in your current job? If you're doing a lot of, you're trying to analyze your data, which you're getting from your various sensors and machines, then you can, and if you're not doing that, it is recommended that you do that, and then you can get into Hadoop. Okay. Okay. I know both Java and Python. Which one is more best? Okay. Well, Nissan, it's your choice and depends upon your company's requirements as well. Both Java and Python are highly in demand in Hadoop. So you may both have, Java has various packages. Python also has various packages specifically for data analysis. Okay. Okay. So there are a lot of questions here. What I'll do is I'll move on now. Okay, Srinivas, I can see your questions. But what we'll do is I'll stay back after the session as well, and I can answer more queries on related to your specific background. I think I've covered most of them now, but if you have very specific queries to your background, I'll be happy to stay back. Okay. So let's move on and let's understand the Hadoop ecosystem, and then this will give you more understanding on where you will fit in. Okay, so as I said, Apache Hadoop is a framework that allows distributed processing of large data sets across clusters of commodity computers using a simple programming model. Now, there are two things which we've talked about here: clusters of commodity computers and a simple programming model. So these clusters of commodity computers are used to store your data, and this simple programming model, which is called MapReduce, is for analyzing this data and retrieving that data back. Okay, it's an open source tool, so you don't have to pay for heavily for licenses. Now there are two core. So this is how the Hadoop ecosystem looks like. Now this what we've been waiting for. To start with, let's look at what is the kind of data you have and how do you move that data into Hadoop. Okay, so you can have structured data which can be in your RDBMS or any other structured data format. You can use Scoop, which is a abbreviation for abbreviation for SQL to Hadoop. It is a tool in the Hadoop ecosystem using which you can move your data from any traditional RDBMS into Hadoop. So you can move it from MySQL to Hadoop. You can move from Oracle to Hadoop. You can move from SQL Server to Hadoop. And other databases to Hadoop. There are connectors available in Scoop to move any data, structured data into Hadoop. Okay, so this is the first step of you have to move your data into Hadoop. This is what you use. Okay, then there's a tool called Flume, which is used for importing or exporting all your unstructured data. Say, for example, you have web logs, okay, which are streaming, which is a streaming data, and how do you move that into Hadoop? So Flume is the tool which is used to move that data into Hadoop. Okay, so you can move your data from, say, Facebook. You can move your data from Twitter using APIs into Hadoop. You can use your data which is unstructured email data or any other data which is available as web logs into Hadoop using Flume. So these are the two major tools for moving your data into Hadoop. Now, when we say Hadoop, Hadoop has two core components. One is the HDFS, which is the Hadoop distributed file system. This is not this is the cluster of computers I was referring to. So this has the HDFS has thousands of computers or storage machines where you can actually store your data, and there is a name node architecture which can actually store the metadata of this about all this data. So this is the layer where your actual data is stored. Okay, this is called the HDFS, Hadoop Distributed File System. Okay, all your data in Hadoop is stored as is. So you can store your videos, audios, everything, as well as your transaction, all your structured data as well. Okay, so you can move all your data into Hadoop. There's no restriction on the type of data you can move into Hadoop. Okay. Now, this is where your DBAs and administrators come into play, setting up this cluster, managing this cluster, making sure that the cluster is up and running, the security side of this clusters, all this is taken care by the administrator. So anyone who's from an admin background can move into this layer of Hadoop. This is where you will be working in. Okay. Then you have your MapReduce framework on top of this HDFS, which is basically the framework for retrieving this data, running your applications on Hadoop. Okay, and so the way this MapReduce framework works is that whenever you write your program in Hadoop, whether it is Java, Python, Perl, or any other higher level tool like Hive or Pig, this program is divided into a map program and a reduce program. And this map program goes to the cluster where your actual data is stored. So instead of moving your data towards the compute grid, your program itself is moved to the cluster, and you analyze you run your program there. The output of this program is fed into a reduce program, which is nothing but an aggregation kind of program, where you can analyze all the data which you got as output from the map program, and then finally you get your results outside this program. Now, we are not going into the details of this. This is covered in a lot of detail in the courses which we offer. So if you're interested in learning more into it, and then there are a few more webinars and blogs where you can understand this further. I can give you the links at the end of this session where you can understand the MapReduce framework more in detail. But just to understand it here, that the HDFS is the layer where all your data is stored. MapReduce is the framework which runs and analyzes your programs. Okay, so you move your program to the actual location of the data, get the result of that program, and then aggregate this all in your reduce program. So it's like a typical analogy will be that, okay, you're having elections somewhere, and all your people voted at the various constituencies, and finally what you did was that you counted your votes at various constituencies. That can be your map program, and then you finally sent this counting to a central location where you declared the result, and that program which did that counting could be a reduced program. And there are many more applications, but just to give you an example. So I hope this is clear now. So these are the two core components of the Hadoop architecture, the HDFS and the MapReduce framework. Okay, and the MapReduce framework is where all your developers, QA professionals can get into. Okay, so that's where the opportunity lies from. Whether you're from the Java background, or you're from the Python background, or you're from the .NET background, this is where you can get into. Okay, so, and if you're from the QA background, this is where you will be working on mostly. Okay, okay, so okay, so now, files stored in disks. Yes. So all these files will be stored in disks. Suresh, I'll talk about Mahout as well just in a while. Okay. So now all these files are stored in the disks. Okay. And then is MapReduce across a cluster of computers. So you can imagine that you have thousands of machines where this data is clustered and stored. Okay. So is MapReduce programming must to enter into Hadoop? Well, not really. I mean, you need not, even if you do not know programming in MapReduce, you have tools like Hive and Pig where you do not need programming in Hadoop. So Hive is the data warehouse system of Hadoop. You can write simple queries which are very similar to your SQL queries. And what Hive does is that internally it will convert whatever you wrote in HQL, which is the Hive query language, into MapReduce. Okay. Similarly, in Pig, there's a language called Pig Latin, which is again a very simple scripting language. Okay. You can do all your data analysis in Pig, and the Pig tool will convert this into MapReduce, and which can run here. So you need not know programming actually. Even if you are from a non-programming background, this is where you'll get into. So all your ETL, data warehousing professionals or data analysts will be good to will be happy to learn this, because there is no requirement of knowing Java programming, or you need not have a programming background to get into this. Okay. Then you have a very important tool, Mahout here, which is for machine learning. So what does this tool do? Now, this is a collection of inbuilt algorithms for clustering, for classification, for recommendations, which are used. Say, for example, you must have seen when you go to an e-commerce site or Amazon, you see that, okay, recommended products for you, or recommended courses for you, for example. So all that is done at web scale using Mahout. Okay. So what Mahout does is that internally it also is a collection of MapReduce libraries. Okay. So and it will run on the Hadoop framework itself. So but you can just instantiate a library, and you can say that, okay, this is the data which I have, and this is the kind of analysis I want to do. So there are inbuilt libraries for recommendation, clustering, classification in Mahout. Okay. Then there is a tool called Uzi, which is used to manage all this workflow. So if you're running, say, thousands of jobs, you can manage that very easily using Uzi. So these are the various typical components in the Hadoop ecosystem. On top of this whole thing, you can have your R or SAS to analyze the data. Okay. So you can generate reports from Hive on your trend analysis. But if you want to do, say, predictive analysis, you can still have your data here in the HDFS. You can connect your R to your Hadoop. Okay. So whatever you can write MapReduce in R as well. You can write your in SAS or R or any other analytics tool there. In Informatica also, you can connect it to Hadoop, and that will be converted by that tool into a MapReduce program, which will be understandable by the Hadoop ecosystem. And then you can get your data from here. Say, for example, so how does this help? If you're using only R or SAS, now all that data, initially, whatever data you load into R or SAS will be stored in the RAM of that system, right? So you are limited by the amount of data you can analyze. But if you can connect R and Hadoop here, then you can analyze any amount of data. That your scope of analyzing the huge amount of data changes, right? So you can do any kind of predictive analysis on the data which you have in store using Hadoop here, using R. Okay. Now this is only about the internals of Hadoop ecosystem. What are the different type of so this is now coming to the HDFS and MapReduce. Just a review of what I just said. So it has two core components. Hadoop distributed file system, which is for storing, which is highly fault tolerant. You have high throughput access to application data. It is suitable for applications which have large data sets. So if your large data sets are huge, then only you should move into Hadoop. Okay. And it is natively redundant, which means that even if some of your machines or some of your storage devices fail, it stores multiple copies of your data. The HDFS itself takes care of that, and you don't have to worry about worrying about the failures here. Okay. Then the MapReduce, which is the software program framework, you can write your applications very easily in MapReduce, and you can do parallel computing on these. Now, there was a question that how is it different from parallel computing? Okay. Now, that's a very good question. I did not answer that question then. So this is the time to answer that question. Well, parallel computing means that you have distributed your computing onto various processors. Okay. You're not really limited, or you're not really challenged by the kind of data you are working on. In MapReduce, you're not limited by the processing power, but the fact that you have a huge amount of data, and moving this data to your compute grid is the challenge. So what this does is that your small programs are moved across the locations where your data is stored. Okay, so you actually send your program to the location where your data is stored. That computation may not be huge. It may not be very complex. It can be a simple conversion of one format to another. Okay, it can be a simple aggregation of results. where, but the challenge is, since your data is so huge, and moving that data into your compute grid, if you were planning to do that, is the challenge. So you, instead of moving your data to the compute grid, what you're doing is you're moving your program to the data where the data is stored. Okay, while in parallel computing you have a complex algorithm which you're trying to crack, maybe a SATI kind of thing, or maybe a genome which you're trying to decode. You have a huge computation task where you are trying to take the benefit of the computation power of your grid. Okay, whereas in this case you're trying to take benefit of the storage power of your cluster. Okay, so I hope that clarifies. So the distributed between the distance between the parallel computing and Hadoop processing is clear, please. Can I get a quick yes, and I can take questions on that? So in parallel computing, essentially what you're utilizing your compute grids computation power or your processing power. In Hadoop, the challenge is not the processing algorithm, but the fact that the data is so huge, and so moving that data to the compute grid will be huge. So even if your computation is very small, you still want to move that compute or that program to the data instead of moving the data to the program. Okay, is that clear? Can I get a quick yes if this is clear to everyone, guys? This is a very important question. If you're attending interviews also, this will be asked. So if this is clear, then give me a quick yes. Okay, great. Thank you very much. Okay. Now there are a few more questions which I'll take, which are really related to this. So is Hadoop a good choice for business analyst? Well, yes, Satya, definitely. If you're a business analyst, you may want to understand the Hadoop architecture, but I'll recommend you getting learning tools like R, where you can actually do a lot of analysis. You can do a lot of statistical analysis. You can do a lot of predictive analysis. That's where you will fit in best. Okay, instead of getting to the Hadoop development. Okay, so for Java programmers, as I said, right, MapReduce is the place. Okay, so MapReduce is for the programmers and Pig of Hive for the ETL professionals. What tool for business analysts to use? Yeah, so as I said, right, I mean, you should, I'll highly recommend you learning R and statistical analysis and predictive analysis there. Okay, Satya? Okay. I'm from SQL background, doing BI work and all. Can I now move to R? Okay, Irana, very good question. Now, if you are already into BI, what you're doing now is you're analyzing the trends, you're analyzing what has happened in the past, right? With R, you can actually look at your data and do analysis on what you can predict in future, right? Who can buy a product, who can who will be your customers, who will retain as a customer. So you can actually learn predictive analysis, and that will make your experience very, very strong. So that's where you can move into analysis, right? Yeah, you will be getting the recording. Okay. Okay. So I can say data locality is not available in PC. Yes. So good question. Data locality optimization is a term which is very commonly used to describe how data is processed in Hadoop. Okay. So what we do is that instead of so what we do is these map programs move to the location where this data is. So instead of running this map program on a central location and you move that data there, you try to figure out, and that's where the Hadoop framework figures out where your actual data is stored, and you move your program there, and you try to run that program as close to the data as possible. It is very much possible that in the same cluster you may want to run the program in a different machine, but it should be run as close as possible so that moving of data is minimal, right? So the biggest challenge is how to move this huge data. Okay. Yeah, you will get the recording of this session, right? Okay. Can you give more example of on Mahout? Sure. So is R or Mahout do the same job? Very good question. Now, both R and Mahout are used for machine learning as well as doing a lot of algorithms on clustering classification. Now, with Mahout, you can do it at web scale. Say, for example, you are a website and you want to do you want to analyze your data and you recommend some systems, some products to some customers, right? Or you want to show some discounts, or you want to say pop up a form for a customer. So on web scale, Mahout is the choice. Mahout does not have all the algorithms which you can do in R, because R is much more powerful in terms of the statistical tools available. But then Mahout is used when you're doing it on a web scale, which is on a huge scale you want to do it. On R, what you can do is that you can do your analysis on your data which you have in Hadoop, or you can do by connecting R to Hadoop, as well as you can do statistical analysis on moving data from various sources into R. Okay, so I hope that clarifies the question. So R has much more power than Mahout in terms of the type of algorithms it can support. Okay, you can do decision trees, you can do random forest. These are all names of the algorithms. I don't want to get into those, but if you're interested in learning these, we have a course on data science as well as in R. You can learn from there, and we also have a special course on Mahout, so you may want to learn from there. But just to give you an overview, R is for R can handle a lot of statistical analysis, and Mahout has a limited set of algorithms, but they're very, very powerful in terms of the amount of data they can handle, and you can really run them on web scale. Okay. So Suresh and Veera, I hope that answers your question. Okay. What is the capacity of Hadoop to handle data? Okay. Now, Hadoop can handle huge amount of data. Now, the reason why it can handle huge amount of data is the fact that you can add as many nodes as possible. Now, there's a caveat here in Hadoop 1.0, which was the earlier system being used. Now, a lot of people are moving to Hadoop 2.0. You were restricted by the size of the number of nodes which you can have. So, 5,000 node was the limit of Hadoop 1.0. But you can imagine with 5,000 nodes with say 2 terabytes of data on each node, you can imagine the kind of data you can handle in Hadoop 1.0 itself. Okay. Now, most of the organizations do not need anything beyond that. Sears, for example, the example which I showed you has a 300 node cluster. So typically you will be able to work with a 3 node or a 5 node cluster as well. And most of the applications will be running on say 20 to 100 node clusters. But say if you are a Yahoo, then you'll probably need a 5,000 node cluster. Or if you're Amazon, you'll need a bigger cluster. So that's where with Hadoop 2.0, that limitation is also removed. And if you want to know more about that, you can look at one of the webinars where I've discussed about the differences between Hadoop 1.0 and 2.0 architecture. You can look at that as well. And you can even join the course to know more about it. Okay. So that is how Hadoop is able to handle almost unlimited amount of data. Okay. So now coming to Hadoop 2.0, where I've not talked about yarn yet, where what are the kind of processing which you can do, what are the kind of applications you can do. Now in Hadoop 1.0, what you had here, the earlier diagram I showed you here, had only MapReduce. Okay, so there was a question right at the beginning that can I do real-time processing using Hadoop? Okay, with Hadoop 1.0, that was not very difficult and not possible. Okay, now what has happened now is that I'm sorry. Yeah. With Hadoop 2.0, you have something called yarn, which is a acronym for yet another resource negotiator, where all your resource management has moved to yarn, and it supports multi-tenancy as well. Multi-tenancy means that you can run any kind of application in parallel on Hadoop. Earlier, you were limited by only the applications which fit into the MapReduce programming paradigm. Now which is a batch kind of processing. So MapReduce is a batch kind of processing where you have stored your data and now you want to analyze that data and do some future predictions. Now you can do an interactive text kind of analysis. You can do online, which is using HBase or any other NoSQL data store. For example, Cassandra, MongoDB, you can connect it and you can do it. You can do a streaming processing or a real-time analytics using Storm, which is another tool in the Hadoop ecosystem. Okay. You can do graph processing. Giraffe is another tool in the which is another Apache process, Apache project, which you can do for graph processing, or you can use Neo4j for that as well. You can do in-memory computation as well, which means that instead of having your data onto the disk, a typical very popular tool for doing this is Spark, which is open source. Then there's HANA, which is again an in-memory tool where you can move petabytes of data into the RAM itself and then do analysis on top of it. Okay. So these are the various applications now which can run natively on top of Hadoop. Earlier, it was not possible to run anything other than MapReduce, which was the batch processing. So if you had to do any kind of streaming analysis, you had to move your data out of Hadoop and put it in a different location and then do streaming analysis. Now Storm is the tool which is very popular in for doing real-time analytics. If you're interested in learning Storm, there's a course on that as well. You can check out on edureka.in website. Okay, so these are the various applications of Hadoop. Now with Yarn coming in, you can do all these kind of applications in Hadoop. Okay, any more questions on this? I'll be able to very happy to answer that. Okay, there's a question from Srinivas. Can we do practical work on our local PC, or do you provide some service with heaps of data to work on? Okay, so the answer to that is both, Gaurav. Okay, now you can also set up a VM on your local PC to do all the practicals, or you can get access to a cluster where you can do analysis on a huge amount of data as well. Okay, but most of your learning can be done locally as well without access to the internet. But then you can get, when you enroll for the course, you can get access to that as well. Okay, you'll get access to the clusters. Okay, what is the major difference between HDFS and HDFS2? Okay, so now HDFS and HDFS2, the major difference which comes in is the way the data is organized and handled. Okay, now earlier in HDFS, you could only run these MapReduce jobs. In HDFS2, you can do much more than that. The Harman, if you want to look, understand that more in detail, there's a free webinar recording which is available. I'll share the link with you guys on the blog itself. You can look at that, which detail gives you detail about the difference between Hadoop 1 and Hadoop 2. Okay. Okay, does Hadoop Pig now work on MapReduce or directly on Yarn? Okay, so it will directly work on Yarn now. Okay, now what happens is that Hadoop, you can write your SQL queries in Hive, you can write your Pig Latin scripts in Pig, and it can directly get into Hadoop. Okay, so you need not write a MapReduce program there. Okay. What is the difference between Yarn and HDFS? Well, HDFS is your storage and Yarn is for your cluster resource management. So Yarn is the framework which runs all your applications, and things like resource allocation, things like failure management is all done by Yarn. Okay. Okay. Is there a certification program recognized by the industry, and how does your course help prepare for that? Well, okay. So there are quite a few industry certifications. There's one from Cloudera which is quite popular. There's one from but there's another from the Cloudera one is the most popular, but then there are other certifications as well. But I think which are popular. This course actually, though it does not prepare you directly for a certification, but it helps you in understanding all the aspects needed to clear any certification. There's a data scientist certification as well. You can take that as well. The other one which I was talking about is from Hortonworks. Sorry about missing that name earlier. So Hortonworks and Cloudera are the two popular certifications. And if you do this course properly, if you do all the practicals, all the projects, you should be able to clear any certification. And more than the certification, you will be able to get hands-on onto Hadoop. So that's the focus of this course, that not only preparing for just a certification exam, you can you can actually learn practical applications and do a project. So the way Edureka also provides you a certificate, but it's slightly different. The way of giving the certificate is slightly different than your traditional certificates. The way we do it is that one project at the end of the course is mandatory for you to qualify for the certificate. So we'll be giving you a set of projects. You'll have to complete one project on your own, and there's a support team to help you out. So that's another thing. So not only the instructor-led classes, but there's a 24/7 support team. In case you're stuck with something, you can ask for live support as well. So with the help of the support team, you have to complete one project to qualify for the first for the certification. Okay, and then you are not limited by that. You have a lifetime access. You can do many courses for that. Okay, now is there any practical sessions? Well, all these courses, this is just an introductory session. Okay, but there will be we will move on. The course will be very practical in the sense that we will be doing all the, we'll be doing a lot of live projects in the course. We'll be doing a lot of case studies in the course. You'll be setting up the Hadoop cluster. You'll be setting up the Hadoop cluster on your own. You'll be doing all these programming, the Hive. You'll learn how to write Hive queries. You'll learn how to write Pig queries. You'll learn how to do analysis on that data. All this will be a part of the course. Okay. Okay. So okay, what is Storm and when this will be used, and any example? Well, good question, Chiranjeevi. Now, Storm is for real-time analytics. Now, real-time analytics refers to the fact that, say, for example, you want to develop a system which can alert you in real time if there is a fraud transaction happening on a credit card. Okay. Now, in Hadoop, that's not possible inherently because Hadoop will store your data. You cannot take streaming data directly from in Hadoop. What you do here is that in Storm, what that helps you in achieving is that you can take your historical data from Hadoop, develop your model through Hadoop, which is in your Hadoop, as well as you can take streaming data. Say you have a data stream coming in on the transactions which are happening, and you can verify these transactions with the model which you built using Hadoop, and then you can alert the customer whether it's a fraudulent transaction or not. Another example where actually Storm was developed was in Twitter, where you show the trending topics at this point of time. So, for example, in World Cup right now, what are the trending topics on the football World Cup right now? Say, for example, Bartoli just yesterday itself tweeted that if we help England get into the finals, I need a kiss from the Queen, right? So that became trending. So how to make because it was tweeted many times. Now this trend analysis on real time is done through Storm in Twitter as well. So that's where Storm is applied. I hope that answers your question. Well, Storm is not a part. Storm is not a part of this course, but there's a separate course on Storm. You can look at that course. Okay. How does certification help? Well, certifications help in establishing the fact that you know the subject well. But I am not a big fan of certifications, though. I don't have any certificate, so I'm not a big fan of certifications. But then at the same time, they help you in, at least shortlisting your profile to your prospective employers. But then finally, it is important that you understand the concepts and you are able to apply them in practicals, right? So practically, if you're able to apply, if you're able to do a 2-3 proof of concepts, you should be good enough to get into that skill gap which Gartner talked about. Okay. Okay. Okay, how do we do indexing and joins in HBase, Madhusudan? This will be a slightly out of the scope of this session, but we have that as a part of the course in HBase. Okay, so you can join the course and learn. Does the course include MapReduce, Pig, Hive, Mahout, and all things you mentioned? Well, yes, the course includes cluster configuration. It includes MapReduce. It includes Pig. It includes Hive. It also gives you a introduction to Mahout. There's a separate course on machine learning with Mahout, so you can take that. But the developer course takes this. There's a separate course for administrators, which is, let me just quickly show you the courses available on the website itself so that you can look at that. Okay, so these are the various courses available here. You have your Hadoop course, which is more for data analysis and developers. There's a Storm course for real-time data analytics. And if you have from a Python background, you can take this course. If you want to become a data scientist, there's the course for you. If you want to learn R, there's a course here for R. If you're a Hadoop administrator, there's a specific course for you where you want to learn Hadoop administration. You want to learn NoSQL data stores, MongoDB and Cassandra are 2 courses available. Then there's a course on Mahout, machine learning with Mahout. Okay, this is a specific course here. Now, the data science course covers both R, it covers your little bit of Hadoop, it also covers your Mahout also. So, but if you want to go deep into R language, then the R course is there. There's the course which will cover predictive analysis and stuff like that. Okay. So, any questions on that? I'll be more than happy to answer them. Okay, what is the difference between data science and business analytics with R? Okay, so good question. Now, the data science course actually tells you various techniques of data acquisition, data cleaning, uh, uh, from a data scientist point of view, and then we also cover Mahout in that. Okay, the R course talks about more from the statistical analysis of this data. The data science course covers more of the clustering algorithms, the customer segmentation algorithms. Okay, so these are the algorithms which are covered in the data science course. Now, depending upon if you're from a slightly technical background, I recommend the data science course. If you're from a non-technical background, and if you're from say a marketing background, if you're an analyst only, then the R course is more recommended for you. Okay, I hope that answers, right. As a developer, I want to continue as a developer. Which two courses should I take? Okay, so if you want to get into there, I recommend you to take the Hadoop course, the big data and Hadoop course that covers mostly from the developer perspective. Okay, and if you want to take that offer which you're talking about, I recommend you to take, there's a Cassandra course which is available on the offer. You can take that course. So that will really complete your thing. From you'll learn big data and NoSQL. So that's what, Srinivas, I'll recommend. Okay. Okay, what's the cost and maintenance of Hadoop and with respect to other tools like ab initio? Okay, so now the biggest advantage with Hadoop is that you are running a open source thing, right? So even if you're using a distribution of Hadoop either from Cloudera or Hortonworks, it is much more cheaper than using any of the licensed tools. Okay, so that's one. The second thing is the kind of machine configurations which you need, okay, is commodity. So you don't really have to invest a lot in the infrastructure as well. The biggest benefit is that you can do all this in cloud, and you can do it in really, really cost effective manner. Okay, best courses for managers to handle big data projects. Okay, so Ramanathan, I'll recommend you the data science course, because that tells you what are the various aspects of data science. If you are from a technical background, if you can understand some technical parts, but you're not really want to get into programming now, data science is the course. Okay, the data science course will require you to know a little bit of understanding of handling of data if you've done it earlier, but pretty much, and it also teaches you a little bit of R as well, whatever is required for data science. So if you have that keen interest on that, and if you know the Hadoop architecture as such, whatever we've talked about here and a little more, then you should be all set. Okay. Uh, Sai, just give me some more time. I'll stay back. I'll unmute you. We'll talk. Okay. I'm a SaaS analyst working on automation and optimization process. How Hadoop is useful for me? Which area of Hadoop should I be looking at? Okay, so if you're a SaaS analyst, I recommend you to look at it from a R plus Hadoop perspective. Okay, so because that's where so Hadoop will be the data store for you. You need not just load your data into SAS or R. You can have your data in Hadoop, and you can run your analysis on top of that using R. Okay. Tell more about HBase. Okay. Now, HBase, MongoDB, Cassandra, all these are NoSQL data stores. Okay. So these are, as Hadoop stores your data in files, you can store your data in a NoSQL store as well for doing, say, online kind of transactions. So there are various categories of NoSQL databases. Now, HBase, and there's something called a cap theorem, based on which we talk more about it in the course. But just to give you an overview, that the challenge with your traditional RDBMS comes in the fact that when your data scales up, you are not able to meet those acid properties which you would have always looked at, right? You have to either compromise on consistency, or the partition tolerance, okay, or the availability of the data. So there are various NoSQL databases depending upon the applications which you have. Say, for example, if you are trying to display your if you are a travel website, and if you are trying to display your prices across your or airlines, or you are a hotel website, you are more concerned about the scale on which you can do it. You don't really worry about the consistency, because two different customers can see two different prices, right? So in that case, Cassandra is the SQL, NoSQL database which comes handy. So all these things happen on Cassandra, whether it is a like button on your Facebook, or a wish list button on your Amazon, or add to my wish list, or view later kind of buttons on YouTube. All these are done through Cassandra. Cassandra is a very, very popular NoSQL database, which where you can tune your consistency, but you can scale to huge amount of data. Okay. Then there is HBase, which is strongly consistent. Say, for example, the Facebook chat which you do, right? You want to make sure that it is consistent, which means that if I type something, I should get a response to that only. It should not happen that that conversation is lost. Okay. And you want to scale a lot. Okay. But you can compromise with the availability. Sometimes if it is not available, that's fine. So there HBase is used. Okay. Then MongoDB is the closest to your traditional RDBMS, where you can cluster your data. You may not scale to as big as Cassandra, but you keep your consistency and availability intact. Okay, so there are different NoSQL databases available. Then if you want to do graph kind of analysis, there's Neo4j. So all these can connect with Hadoop, where see the actual data is still stored in Hadoop. Even if you're using HBase, the actual data is stored in Hadoop, but all your table structure and everything is stored in HBase. Okay, I hope that answers. Okay, how do these tools like Tableau, MicroStrategy, Hyperion, etc. fit here? Now, they'll not be obsolete. Well, Tableau, all these tools will actually can get access to a bigger data now. You can still connect these tools to your Hadoop ecosystem and do this. Okay. For C++ developers, is data science advisable? Well, Arjunan, if you're a C++ developer and if you're interested in getting into data science, yes, you can definitely get into it. You'll have to learn a few more things, obviously, but there's no restriction, right? I'm from a system administration background. I'm at a career level where I get paid between 16 to 17 lakhs per annum. How Hadoop administration can help me take to the next level. Okay. Well, Hadoop, you can get into Hadoop administration and architecture, Rajveer. You can surely get there. I think Hadoop administration will be a very lucrative task, job for you, where you can look at organization's needs, and based on that, you can architect the system which will be required to handle that kind of data. Okay, so Hadoop administration is there for you. Okay. Okay. So, is there a live example of Hadoop? Uh, okay. Implementation into patient data management, care coordination, etc. Well, yes, Hadoop has a big application on medical side of things. So hospitals use Hadoop. So I mean, I do not know the exact name right now, but you can look at one of the Edureka blogs where we've taken a case study on one of the huge hospital chains using Hadoop for managing their data and the patient data. And also, see, Storm also comes into play there. Say, for example, if a doctor wants to, depending upon the various tests and say a BP or a temperature or any other test, if you want to send an alert to a doctor that, okay, this is the patient where you need to visit in a big hospital, Storm is the place where you can do that. You can do real-time analytics there. So there's a huge application for this in Jizzle in medical side of things as well. Okay, I hope that answers. Okay. For genome analysis, Hadoop is very much recommended. Yes, for if you're doing genome analysis, Hadoop. I mean, since you have a huge amount of data, I think genome analysis is a big application of data science. Okay, so data scientist, data analyst, and data visualization. Okay, as a data scientist, you will be expected to understand how to get data from various sources, how to clean that data, how to run various algorithms on that data, and also how to visualize that data using, say, R or any other data visualization tools. Okay. Okay. So I hope that answers. I'm a business analyst in aero domain. Which Hadoop related course will help me? Okay, so if you're a business analyst, I would recommend the R course for you, Ranjit. Okay, how fast would the process be the process when we query R SAS from Hadoop component or other data warehouse software? Okay, so very good question. If you do it from R SAS to Hadoop, it will be very fast because all your data is available. As compared to any other data warehouse software, it will be slower because you do not have access to all your data. As I said in the Sears case study, I mean 90% of your data will be archived. In Hadoop, you have access to all your data. And since this all this data access can all this, so what you do is you don't get your data into R. What you do is in R you can write a program or a macro which can run on this data and get you the results quickly. So that's the basic difference. You don't move your data into the compute grid. That's why it's much more faster. I hope that answers your question, Kushal. Okay. Sai, we can connect offline as well. So you can drop me an email at abhishek@edureka and we can talk. Okay. Okay. Abhishek, I want a course to get real time experience to get a job. Suresh, depending upon your profile, right? All these courses which I've talked about, we get into real time live examples there. We you have to do a project at the end of the course. So definitely you can choose any of these courses we talked about. All these courses are really use real life examples, and you do live projects at the end of all these courses. Depending upon the course you want to do, you can choose any of those. Okay. Now I have 2.5 years of IT experience. It is the right time to move into Hadoop, or is it too early? Vipul, it is never too early. I mean, it is a very good time if you have 2.5 years of experience. There's a huge, I mean, even there are openings of freshers as well. So definitely you can get in. Okay. Can use Hadoop be used as integration tools like .NET? Yes. So there are, you can use Hadoop streaming to actually connect your .NET programs into Hadoop. Okay. There's something. Ranjit, can you please quickly repeat your question? I'm sorry about that. So Suresh, you can pick the big data course that will help you out. Okay. I'm sorry, Ranjit, I probably missed your question somewhere. You can just put your question once again. And if you guys are interested in enrolling, you can directly click on the course, or you can even type it in the chat window saying enroll, and the team will get in touch with you. And don't forget to fill in the survey report at the end of the session. Okay. Please give more details on about Pig and Hive. Durai Morgan is asking this question. Is it like ETL tools based or UI or programmatic tools? Okay, good. So, well, both Pig and Hive are very simple in the sense that Hive has something called HQL, where you can write queries. There is a UI interface also available. So you can write very simple queries like you would do in your normal business scenarios. You don't have to do a lot of programming there. And this will be converted into MapReduce, which will be run on Hadoop in turn. Okay, so you don't have to really worry about programming for Hive or Pig. Pig also has something data analysis language, which is very simple language. It's called Pig Latin. We cover both these languages in detail in the big data course. Okay. Hadoop Hadoop tools like R and Mahout can be used to store and process data in other NoSQL databases like MongoDB and Cassandra. Well, the thing is that Hadoop will be used to store the data. You can connect Cassandra or MongoDB depending upon your NoSQL, depending upon your requirement or your use case, and then you can do R and Mahout for. Mahout can be used for web scale machine learning. Can be used for any level of statistical analysis on that data. Okay. Which all Indian companies are currently hiring Hadoop admins? I don't know the answer to that question, but let me tell you. Let me tell you, all the companies are hiring, whether it is large service organizations or product organizations. Everyone is actually requires people in Hadoop. Okay, so you can search in any of these job sites, or there is another blog which Edureka has. You can check with that. But there's a huge amount of requirement for Hadoop admins as well. would be interested to know about the instructor's experience in Hadoop MapReduce and complexity or the volume of the data handle. Okay, so great. So Ranjit, that was your question. Well, if you tell me, if I tell you about myself, or I'll tell you about generally who are the instructors. So most of the instructors with Edureka are professionals, very senior, typically 15 to 20 years of experience, of and they typically work as senior architects and solution architects in their respective organizations, working and have a typical experience of around 3 to 4 years in the related technologies. That's how the instructors are chosen. I'm also one of that panel. Okay, so about my experience, I have around 20 odd years overall in the industry. I've been part of this big data thing for last 5 years. Right from the beginning of the things, I was a part of it. And so you can expect, I mean, all the instructors will be able to give you real examples, and I mean, they'll be able to share their real experience with you. So don't worry about that. Okay. What's your view on Hadoop versus Teradata in terms of query processing speed? Well, see, and system high availability. Well, if your data is small enough, less than 10 terabytes, Srikanth, then you can very well do everything in Teradata. Okay, and obviously query processing will be much more complex. Query processing can be done in Teradata as compared to Hadoop. But if your data becomes huge, then you have to get into Hadoop. Okay, so that's how I compare it. I'm not saying that everyone should move into Hadoop. Okay, if your data is small enough and if you have complex queries, then probably remaining in Teradata will be a better idea. Okay. As a database developer, I would recommend you to learn the big data course, which will tell you about the Hive. Hive will be the best part for you. That's what you'll be doing. Pig and Hive are the two things which you'll be doing. Okay. Okay. So I have no Java or no technical experience. Can I get into Hadoop? Well, if you do not have a Java or technical experience, you can still get into analysis. If you have some analysis on some experience in analyzing data, you can definitely move in. Okay, but you'll have to learn a few things there. Okay, Ranjit, I hope that answers your question. If you have any specific query, I'll be more than happy to answer that. Okay. So, well, all the instructors who we have, there are multiple instructors who take these classes. We have a panel of instructors. Okay, now all these people, as I said, right, are typically with 15 to 20 years of experience, who have a lot of experience in handling large data projects. So that's how the instructors are. Okay, I'm also a part of that. Okay. So what is Cloudera, and was it, where is it used? How is it different from Hadoop or a part of it? Okay. So Cloudera is a Hadoop distribution. Okay. Now Hadoop is an open source tool. Okay. Well, while you can draw that analogy between, say, Red Hat Linux and Unix. Okay. So Unix is open source. Red Hat Linux is a distribution of Unix. Similarly, there are multiple enterprise level distributions of Hadoop. Cloudera is one of the more popular ones. Hortonworks is another one. What these people do is that it is the same open source tool, but they've built a few applications over it, and they provide you support over it. Okay, so that's how Cloudera and Hortonworks are with respect to Hadoop. I hope that answers your question. Well, Ranjit, it depends upon the batch you are opting for. Okay, so if you go to this the course, you'll see multiple batches. So depending upon the batch you are opting for, you will get an instructor. You can ask the team that you can ask the sales team about who is the instructor. They can give you the profile of the instructor, and they can also share a recording of that instructor. I hope that helps, right? If you're asking about a specific batch, then I mean, these people can answer that question. But there are multiple people who take this course. Okay. I hope that clarifies. Okay. So I heard there's graph analytics. Okay. Yes, Suresh. So graph analysis can be done through graph analysis refers to complex analysis on situations like, say, a Facebook. If if you've searched anything on Facebook, right, you can search that. Okay, who are my friends who are recommending a product, or who are recommending a restaurant, right? So that requires a complex relationship between different entities, and that's where graph analysis come into play. So So that there's a very popular database for doing that, which is called Neo4j. So you use that for graph analysis. Okay. If one has to move into internet industry, okay, digital marketing role and web analytics. Okay. Uh, that for that, Herman, I recommend you the R course, because most of the marketing professionals, right, will be looking at doing these analyzing their customer behavior data, and R has very strong packages for doing that. And that covers predictive analysis as well. So that's the course I'll recommend. Okay. Okay. So what is the difference between Apache Hadoop and Amazon S4? Okay, so now there are the inherent difference which I said about Hadoop, right? Hadoop will be used for storing all this data. Now you can the actual storage of this data can be done on, say, Amazon Web Services. You can take the infrastructure on that. S4 is basically Amazon technology for doing real-time analytics, which is a counterpart of Apache Storm. Okay. uh, is cloud data distribution available for commercial purpose as well? Yes, it is. It is. I mean, it is an enterprise thing. Okay. Okay. My career aspiration is to become data scientist. So please advise whether the right path, Hadoop, R programming, data science. Well, the right path I would suggest will be Hadoop and data science. The data science course, if you look at, covers the R programming part as well. Now, what it does not cover and what is covered in R programming course specifically is a lot of things on the for people from the marketing side, right? So for professionals who are looking at various type of statistical analysis, that's what covered in the R course. But I think you can safely start with Hadoop and then move into data science. Okay. What is the difference between Storm and Spark? Okay, good question. Now, what Storm does is that it can do analysis on streaming data. So if you have streaming data coming in, you can analyze that data. The architecture of Storm is such that at various nodes, it keeps on analyzing data and passes on this data. The data is always coming into the system. Okay. Whereas in Spark, that is in memory computation, which means that you have your data stored somewhere, you move the huge amount of data into your RAM itself, okay, and then you do analytics over it. So Storm is largely for streaming data, where the data is continuously coming in and you are doing some analysis on top of that. Say, for example, Twitter trend analysis. Or say, for example, you want to say that, okay, there is a lot of data which you're getting from sensors from a pipeline, okay, and you want to, based on various factors of pressure, temperature, and say the total load, you want to preemptively figure out whether there will be a leakage or there will be a disruption there. So all these things, or say a credit card fraudulent transaction, all these places are where you have a continuous stream of data coming in. So that's where Storm is used. With as compared to that, Spark is used in places where you have, say, for example, you have a huge amount of data in Hadoop. Now that data is not available all the time in real time, in the sense that you can get some data into your system and then do some analysis. You can do only batch processing in Hadoop. But with Spark, since you're in memory, it is an in-memory database, you can move a huge amount of data. Typically, you are restricted by, say, a terabyte of data. Now, in this, a few gigabytes of data in your RAM, right? In Spark, you can move a huge amount of data, a few terabytes of data into your memory itself, and you can do analysis over it. Say, for example, you are a retail store and and a customer comes in, and depending upon his last purchase, you want to quickly give him an offer, right? So that's where you can use Spark on a point of sale system. Okay. So I hope that is answered. Okay. Nitin, I'll just take your question. Okay. Okay. So you are a .NET professional. Okay. Presently working in operations using Toad. I'm using SQL query to only to fetch data from our tables. I would recommend you to you can say there are two things which you can do. If you want to get into a NoSQL, you can take a MongoDB course. That will be a very good thing for you. Okay. Or if you want to learn the Hadoop ecosystem and say then you may want to concentrate on the Hive and the NoSQL part of this course. Okay. So the big data course or the MongoDB course is what I recommend for you. Okay. Is Cloudera distribution available for free of cost of commercial purpose too? To a certain extent, yes. If you're scaling up to a certain amount of nodes, you can get it free. But then otherwise, it's not very costly. It's not as costly as your typical Oracle system, right? Okay. So what exactly is the data scientist and how is it different from DB developer or DB BI engineer? How that lead to Hadoop? They may be out of scope, but wanted to know. Sure, Prabnath. I mean, this is not really out of scope. Okay, so Suresh, I'll just take your question. Okay, so now a data scientist's role is not only to do a business intelligence, but to do beyond that. Okay, now a business intelligence engineer or a business intelligence architect, what they'll be doing is they'll be architecting systems to generate reports on what is happening and what has happened in the past, right? But as a data scientist, you will be expected to analyze your data, okay, as well as to predict what is going to happen. So what you do typically as a data scientist is that you develop clusters. You say, for example, I'll take an example. So say, for example, I uh, I want to open a few service centers, okay, for my organization, okay, and I want to, or let's say, take an example of Pizza Hut, right? So if Pizza Hut wants to open delivery centers in a new city, right, and they want to understand what should be the locations of these centers so that they are able to serve all their customers well in time and they are able to maximize their profits by uh, minimizing the delivery overall kilometers, right? So what they can do is they can look at various pockets of populations which will be the target audiences, okay, and then uh, try a technique, use k-means clustering, where you can actually say pick three centers for Pizza Hut, okay, and then try to do k-means clustering to figure out what will be the optimum number of centers which should open and what will be the optimum locations of these centers to open so that you can serve all your customers with the minimum expense. So this is a role of a data scientist, for example, whereas a BI guy in a Pizza Hut will be analyzing who are the type of customers who buy our products, or what is the trend, what kind of products are getting picked in the market now, and what are the products which are losing their sheen now. So this is the typical difference. So a data scientist will be able to tell you what should you do, and a BI person will be able to tell you what is happening. I hope that answers your question. What are the algorithms to deal with unstructured data in Hadoop? Well, all these clustering algorithms, the k-mean clustering, random forest, all these algorithms are used to do these things. Okay. For analyzing videos and photos, which one is recommended? Well, there are ways to convert your videos and photos into data which can be analyzed, and depending upon the analysis which you're doing, you will be using the algorithm. So if you're trying to do clustering of your data, then you'll use a clustering algorithm. If you want to do segmentation of your customers, say for example you want to segment your customers into affluent customers, not so affluent customers, and people who are most likely to buy, that's customer segmentation. There are classification algorithms available to do that, okay, and these are both available in R as well as in Mahout. Okay. Now, I've heard Hadoop is also used for analyzing streaming data. Well, not really analyzing streaming data, but to move streaming data into, say, a system like Hadoop or Storm. Okay. So it's a tool for acquiring data, not for analyzing it. Okay. So Spark is not real-time big data analytics tool. Uh, not in the truest sense, Suresh. Spark is not real time, but Spark can handle a huge amount of data in memory, so it's very very fast. So when you say, can you give me results in real time? Yes, but is it can it you do analyze streaming data? Then no. Okay, I hope that clarifies. Can Hadoop help in artificial intelligence? Yes, definitely. So that's what I mean. If you look at artificial intelligence, that's what it is, right? A machine can know, depending upon the actions, There is something called supervised and unsupervised learning. So both fall into artificial intelligence, and Hadoop is the storage for doing that, right? But there are algorithms for doing that. Mahout is the tool which does all these things. Okay. Okay, so our PC should have that much RAM to support in-memory processing. Well, if you're using Spark, then you need to have a system which has that kind of memory. Yes. Can Hadoop even handle zettabyte of data? Yes, it can. I have 1 TB of data and 2 GB RAM. How can I move? Okay, so well, if you have 1 TB of data, let's assume that you have more than that. Okay, so you'll put your data. If you put your data into Hadoop, and then you have your and what you'll do is that your data will be in Hadoop, and whenever you're analyzing that data, Hadoop will not move your data into that's the beauty there. It will not move the data into your RAM, but the process, it will move the program to the data, do that analysis, and bring that data, bring only the result of that data into your memory. Okay. Now, there's another question from S. Jha, that is there any disadvantage of using Hadoop if the data volume is low? Okay, so now, yes. So if your data volume is really low, it's not recommended to use Hadoop, because the overheads associated with, say, breaking of these files, storing of these files will be much more than actually the advantages you'll get. So what I recommend is that if you do have a small data, then you don't need to use Hadoop. If you have data upwards of, say, 10 terabytes, or if you expect your data to go above upwards of 10 terabytes, then that is the time when you should move into it. Okay. Okay. So I hope I've answered most of the questions. You can also put your questions on Twitter. I'll be able to answer them, or you can just put those questions on this. There are some further reading documents, or this is the place where you will get your recording and the PPT for this presentation. You can put your questions there as well in the blog. We'll be answering them. And if you're interested in taking up these courses, you're most welcome. You can choose any of these courses. There are batches and the associated prices available there, and you can enroll for any of these courses. You can look at one of the sample class recordings as well, and you can take a decision based on that. Okay. Any more questions, guys? Else I'll close this session now. Okay. Okay. Thank you very much, guys, for joining in. Really appreciate your time, and I hope it was worth it. Okay. Okay, so yeah, this thing is available. Joy, I mean, see, for mobile analytics, there's no special course, but a lot of this mobile analytics, the way we do it is that you do this analytics in either in Mahout, and you represent that on a mobile. Okay, so you can build an Android app on top of your application, which can be used for analyzing that data. Okay, so if you're really interested in mobile, you may want to choose the data science or the R course or the machine learning course along with the Android course. Okay. Yeah, the recording location will be, as I showed you in the presentation, it will be available on the same blog. Okay, I'll just type it in here as well. So the recording will be available here in the next 24 hours. So that this is the place where you can get the recording, and if you're interested in any of these courses, you can go ahead and sign up for these courses. There are upcoming batches on all the courses available on the website itself. And any other questions you have, please feel free to. I'm sorry if I was not able to answer some of the questions. There were a lot of participants today, so you can put those questions in that blog comments. We'll answer them from there, or you can send these questions to us on that blog. Okay, or you can write those questions at using this hashtag Ask Edureka. We'll be answering those questions on Twitter as well live. Okay, thank you very much for your time and patience, and I hope you enjoyed the session. Before opting out, please don't forget to fill in the survey form. Okay, thank you very much.